Our next example is a verify question as well. We're trying to show that 2 cosine 2x over sine 2x is equal to cotan x minus tangent x. So again, I'm going to start by putting my line down the center. I've got my green box of double formulas here in the screen so that it's easier to work with. Now, I guess one of my first questions for you is this, is if I have, because I'm looking at this left-hand side and I see a cosine over a sine, do you think cosine 2x over sine 2x, cosine over sine is cotangent, would this rewrite as cotan 2x? And that's true, that would. Do I think it's helpful here? And I would say not necessarily, because what we have is a sum on the other side. So I think that's not the best option for us to do. But I do want you to realize that yes, that is a true statement right there. Now, I'm going to start with the bottom because the bottom's a little bit easier. Cosine 2x is, or I'm sorry, sine 2x is 2 sine x cosine x. So I'm just going to start with a big fraction line and we'll come back to the top there. The bottom becomes 2 sine x cosine x. The top's going to have a 2 in it. Now, the reason I said the bottom is easier is because it's sine 2x, and sine 2x only has one option. But when I look at the top here, the top is a cosine. Now I've got 3 different options to choose from, and this is where you might choose the wrong option. Plain and simple, you might pick the wrong option. Now, I want to try to get to cotangent minus tangent, and so the one thing I like is all of these have a subtraction in them, and that's good. Our next question is a verify question as well, and this one's a little bit trickier. And the reason this one's a little bit trickier is it involves a cosine 2x. Cosine 2x is always a little bit more difficult because of the different options you have for cosine 2 times an angle. So that's going to provide or prove a little bit more challenging. Now, the other thing I notice here, I'm going to work with the left-hand side because I think there's a little bit more that we can do. And I notice that we have a cosine 2x over a sine 2x. So the first thing I just want to ask a quick question. Do you think cosine 2x over sine 2x, do you think that would become cotan 2x? Like, can I rewrite this as the cotangent, which is cosine over sine, of the angle 2x? And the answer to that is yes, you can. I don't think it's helpful, but you can do that. I just want to clear that up, that potentially you're thinking that, yes, it's totally you can do that. I'm going to go back to the left-hand side and I'm going to work separately with the top and the bottom. The bottom's a little bit easier to work with because there's only one option. So on the bottom, cosine or sine 2x is going to be 2 sine x cosine x. Now on the top, we have to make a choice. Do we want to use cosine squared minus sine squared? Do we want 2 cosine squared minus 1 or 1 minus 2 sine squared? Now the question is, can I use any of them and would they all work? And I'm going to say maybe. Sometimes they all work. Sometimes it just becomes so difficult with one versus another that it doesn't work out well. Looking at this, I think we should try the top one. Now here's my thinking. There's a cosine squared minus a sine squared. So there's the subtraction. There's no additional 2 that I have to deal with because I don't see a 2 in my answer. I see a subtraction, which is why I like that piece of it. So let's give this one a try. I'm going to say cosine squared x minus sine squared x. And we have a 2 from the original piece. So if I look at my original question here, I just filled in the cosine 2x, but there's still a 2 out in front. And that's okay, because what I notice is that when I brought in the bottom sine 2x identity, I introduced a 2. So those 2's are going to cancel out. And now I have cosine squared x minus sine squared x over sine x cosine x. Okay, so now looking at this, everything is in terms of sine and cosine, which is a good sign. Nothing can cancel as is, but it feels like you should be able to cancel things. So what I'm going to do is use the strategy of separating these two out. Cosine squared x over the denominator, sine x, cosine x, minus sine squared x over the denominator, sine x, cosine x. The benefit of doing this is it's separating the sum that's on top, which is then going to allow me to do some canceling. So now this square on the cosine is going to cancel with the cosine on bottom, and I'm going to be left with cosine x over sine x, minus the square on the sine is going to cancel with the sine x, and I get a sine x over cosine x. Now that's good, because as I look to my answer, I want this to be equal to cotan x minus tangent x, and it is. I ran out of room there, sorry. But by having cosine over sine minus sine over cosine, we get our answer of cotan minus tangent. Okay, here's our last question. Our last question is a numerical question. We saw these yesterday with our sum and difference formulas. I'm just moving this up here so that we can see everything we need to see here. Most of everything. There we go. That's a good spot. So these are questions that give you some information about cosine of theta, and then we're going to use that to help us answer cosine of 2 theta. In this case, cosine of 2 theta and tan 2 theta. So we're given that cosine theta is negative 12/13 and theta is between 90 and 180, which means theta is in the second quadrant. So the first thing I need is cosine 2 theta. So I'm going to go to my formulas first. I have 3 formulas to choose from. And it makes no difference which one we choose here, but I'm going to be really strategic about it. I know something about cosine theta. So if I want to do the least amount of work, is there a formula that only involves cosine? And there is. It's the middle formula. So that's what I'm going to use. So cosine 2 theta is equal to 2 cosine theta squared minus 1. Well, this again is the same thing as 2 times cosine of theta squared minus 1. And we know cosine of theta is negative 12/13. So where there's a cosine theta, I can say negative 12/13 in its place. From there, negative 12/13, well, that's 144 over 169. So that's 288 over 169 minus 169 over 169, which means we get a final answer. I'm going to do my calculator so I don't make a mistake here. 119 over 169. And I don't think that reduces. Let me check real quick. It does not. There's your final answer. Now realize that maybe theta is in the second quadrant, but when I double theta, it's moving it into either 2 theta would be anywhere between 180 and 360. So it appears, because cosine 2 theta is positive, it appears that this must be a 4th quadrant angle for 2 theta. But that's what we're looking for. We're not using a calculator. This is not a question that you would need a calculator for. It's a question that we're able to do without. Part B is going to be the same idea. Part B, we only have one formula we can use for tan 2 theta, so I'm going to start with the formula. Just writing that formula down, I think, is really helpful because it gives you a guide to follow. So 2 tan theta over 1 minus tan theta squared. So to do this question, similar to how we did the last question, we first need to know what's the tangent of theta. So I have to do a little side work. I'm going to go up above here where I have a little bit of space. Here's what we know. We're in the second quadrant. This is technically theta. This is its reference angle. And I know its cosine value is negative 12/13. So that's the adjacent side over the hypotenuse. From my Pythagorean triples, I know that the y value, or the opposite side, must be 5. And so now I can find that tan theta must be opposite 5 over adjacent negative 12. So now I'm going to go down to my formula. Where I see tan theta, I'm going to put negative 5/12 in. And then I'm going to start cleaning this up. Let's say we get negative 5/6 on top over 1 minus 25 1/44, which is 119. We're seeing that same number in there. So we've got negative 5/6 over, what do we have? 1/19 over 1/44. Keep the top, flip the bottom, change it to multiplication. So I'm doing the calculation right now. 6 times 1/19. I get just over 1, so negative 1/20, or negative 120 over 119. There's my tangent. Now, as I said in part A, I speculated that if I double my angle, so here's what I'm talking about. If my angle theta is between 90 and 180, then 2 theta must be between 360 and 180, because I doubled everything. Okay, well, that's either the third or the fourth quadrant. Well, if cosine is positive and tan 2 theta is negative, this must be a fourth quadrant angle. One last question here. Example 7 is very similar. So let me put my picture here so that we can work with it. We are given that the cosine of theta is negative 20/29. It's in, theta's in between 180 and 270, so theta's in the third quadrant. And we want to find cosecant of 2 theta. So I'm going to start this way. Cosecant is the reciprocal of sine. So I'm going to start with sine 2 theta. And once I find sine, I'm just going to flip the fraction. So the formula we have for sine 2 theta is 2 sine theta cosine theta. So I know cosine theta is negative 20/29. So now I have to find the sine of theta. So I'm going to draw a picture over here. We're in the third quadrant. This is technically theta, but this is the reference angle we are working from. We've got cosine, so negative 20 on the adjacent side, 29 on the hypotenuse. We can say y squared plus negative 20 squared equals 29 squared. And we'll get, I don't remember this one off the top of my head, 441. That's a perfect square of 21. So it is a Pythagorean, and this is going to be negative because the y direction here is negative. So I know sine theta is opposite negative 21 over hypotenuse 29. So here's what we're getting. 2 times 21 times 20 gives me 840. (840 over 841).